So the next segment is about model training, how we can use like whatever we discussed about Pytorch tensors and all those functions, how we can utilize that to define our architectures and how we can train that architecture. We just look at the toy example. Of course, that was a very simplistic view. We'll have to build like more complex architectures to actually solve real problems. So let's go through the full training process. When you will solve any problem, you will have to follow these steps. Okay? The first step is you'll have to define the neural network. And the idea is like, whatever problem you have, you should know what will be the input. You should know what will be the output. Okay. So based on those 2 pointers and also like how big your network should be and how many layers, how many parameters there should be. So you will have like you will use some experience and make some judgment calls, define all those hyperparameters like number of kernels, size of kernels. Okay, most of that will come with experience. So don't worry about that. But the first step is define the neural network. Then the second step is you will have your training data. And to train your model, you will have to go through each sample of your training data, right? And then train your network. And as we discussed, we do that like in batches. So the idea is you will have to iterate over your training samples batch by batch. Okay, so you need code for that. And we'll go through like how to write that piece of code in Pytorch, which will iterate over all the samples and give your network batches. And your network will be trained on those batches. Okay, so the third step is once you have that piece of code which can give batches to your network, then the question is how that batch will be processed by your network to produce the desired output. All right. And once you do that, you get the desired output, then you should know how to compute the loss. So we'll use that prediction and you will define some loss functions. And that loss function will make use of the ground truth, which you will need to compute the to train the model. That's also called annotation, that you will compare with the predictions and compute some kind of loss. Once you have the loss function, then you'll have to compute the gradients. Okay, so that gradients will do like the back propagation, the backflow into the network to update each and every parameter inside your network. And once you have computed all the gradients, you will use those gradients to update the weights. And if you think about this, in all of this, the actual training is happening in this last step, which we have on this slide, update the weights of the network. That is the code like when actual training is happening, when you're changing the weights values. All right, so let's go through each of these steps one by one. The first step is to build the neural network. I will give you like a simple example, again, which you can easily generalize to like more complex architectures. So Pytorch provides you a package which is called a neural network. So torch.nn for short. Okay. Now, what you need in your architecture when you write the code, and now we are talking about like the actual coding. Okay, so just bear with me. I understand it can be complicated to understand code like through slides, but I will try my best. So what you do is you actually need some kind of forward function which will do the feed forward operation for you, right? So given the data, it will perform all those transformations to generate the output. Okay, so for that operation, you have this neural network.module function or library, which you can use to actually create all the layers in your network. Okay, and then this is like very specific function which you will always need. So whenever you're defining your neural network, you will always need a function which will be named forward. Okay, we'll talk about that, what exactly that function looks like, but just keep that in mind. And that forward function will take the input, which is like your data, and this function will define like the steps as your layers inside your network are actually transforming your data to produce the output. So this is actually the core of your architecture. And that's why we need this like this function. Okay. So that will do the forward function. And for the backward, we really don't have to care about this because PyTorch has like a very efficient way to do that. And we have AutoGrad, which automatically finds the gradients for you so that you don't have to compute the gradients for each and every variable. And all we have to do is like just call this function. Okay, so if you call this function as I showed you earlier, right? So it will do it automatically for you. Don't have to worry. So the only thing we have to worry is about forward function, where we are defining the architecture, the actual architecture of our model. Okay. So let's see how we can do that. We will not be able to cover like even this part, but I will just give you like some high level idea. So you need to import these libraries, which is fine. Nothing special here. You will define a class, and again, you need to understand what classes are in Python, and the assumption is you already know that. So we're not going to talk about what a class is in Python, right? Because this was a prerequisite. So, but I assume you know. But again, if you don't know this, reach out to me, write to me an email. I can sit with you separately to explain you this. But we'll define a class, and we'll define so this net is like name of your architecture. You can use any name you want. The only thing is you'll have to inherit this neural network.module, this package. So this is like fixed. You can't change it. The only thing you can change is the name of your architecture. Again, you will need like an initializer. And again, you should be aware of this, what this init is. This is something, whenever you create an instance of this class, this function is automatically called. Okay, so that's just programming basics. So this will be called, and again, nothing new. You will always have to do this. And this is again a very standard step. So you're just using this, the name of your class, whatever you defined here. Okay, so again, this is initialization. We don't have to worry about it. Then what we'll do is we will create like layers inside this initializer. Okay, we'll talk about that, how to do that. And these layers are something you will first define them. And once you have defined them, then you're going to use those layers in your forward function. Okay, so as I said, you need a forward function, which is mandatory. And the X is going to be the input. So whatever input you have for your network, that's the variable X over here. And then below this, like in this function, we define what kind of transformations you want to perform in your network. So that's the bare minimal you need. And as I said, you don't need to worry about the backward function. So this will be the basic structure of your neural network architecture. Okay, so whatever architecture you create, you at least need this bare minimal. Okay, so maybe just we can take a pause here, and we'll talk about like the next steps in the next lecture.